Hello there, students. Welcome to today's Explainer. We're going to explore the absolute magic of mathematics together, specifically focusing on your grade 8th concepts. We're going to look at numbers in a completely new way, using some really simple rules to uncover some absolutely amazing patterns. Now, can you imagine being able to predict the exact answer to a math problem every single time, before you even write down a single calculation? I know, it sounds a little bit like magic, right? But it's not. It's just mathematics. Let's see exactly how this is possible. I'll be your guide today as we unlock the secrets hidden right inside our numbers. We're going to use simple rules and clear, logical steps. So just think of me as your friendly teacher, guiding you step by step through your chapter on number play. Okay, so here's our lesson plan for today. First, the four-number puzzle. 2, the power of algebra. 3, pairs to make fours. 4, always, sometimes, never. 5, solving secret letter puzzles. And finally, number 6, your turn to explore. Let's jump right into part 1, the four-number puzzle. All right, I want you to imagine a number line right in front of you. 0 is right there in the middle, and the positive numbers go 1, 2, 3, 4, 5, 6, and so on, moving to the right. Let's just pick 4 numbers standing in a row, say 3, 4, 5, and 6. Now, our puzzle is to place addition or subtraction signs, plus or minus, between these 4 numbers in any way we want. Now, take a really close look at these results. We tried a few different combinations. 3 plus 4 plus 5 plus 6 gives us 18, 3 plus 4 minus 5 plus 6 gives 8, and you know what? Even if we pick 5, 6, 7, 8 and mix up the signs, we get 12. And 3 minus 4 minus 5 minus 6 gives negative 12. So, do you notice anything interesting about these final numbers? 18, 8, 12, and negative 12? Well, every single result we got is an even number. And this brings us to a really important word, parity. Parity simply means whether a number is even or odd. Our test shows that the result always has an even parity, meaning every single answer is an even number no matter how we arrange those plus or minus signs. Isn't that cool? Moving on to part 2, the power of algebra. This is where we prove the magic. Let's quickly review our basic rules for parity. If you add or subtract an odd number and an odd number, you always get an even number. Think of 3 plus 3. It equals 6, right? If you combine 2 even numbers, you also get an even number, because 2 plus 2 is 4. You only get an odd number if you mix an odd number and an even number. Now let's see how this builds our proof. We're going to use letters to represent our 4 numbers, A, B, C, and D. Suppose we have the expression A plus B minus C minus D. If we change that plus sign in front of the B to a minus sign, the total value of our answer drops. It drops by the B we just lost, and it drops by another B because we are now subtracting it. So the total difference is exactly 2 times B. So the absolutely crucial point here is this number, 2B. Because the change between any 2 combinations of signs is 2 times a number, that change is always a multiple of 2. And as we know, any multiple of 2 is an even amount. So if you start with an even answer and you change it by an even amount, your new answer is still even. This perfectly proves that the overall parity never shifts. Okay, let's move to part 3, pairs to make fours. Think about all the even numbers for a second. 2, 4, 6, 8, 10, 12. We can actually split these even numbers into 2 separate groups. The first group has numbers that divide perfectly by 4, like 4, 8, and 12. They leave a remainder of 0. But the second group has even numbers that do not divide perfectly by 4, like 2, 6, and 10. If you try to divide these by 4, they always leave a remainder of exactly 2. And this brilliantly illustrates what happens when we add them. We can take 2 even numbers from that second group, the ones with a remainder of 2. Let's write them out as 4 times p plus 2 and 4 times q plus 2. When we add them together, those 2 extra remainders of 2 add up to make a fresh 4, because, 2 plus 2 is 4. This makes the final sum a perfect multiple of 4. For example, 6 plus 10 equals 16, and 16 is exactly 4 times 4. That brings us to part 4, always, sometimes, or never. It's time for a quick test. I want you to listen to these 2 mathematical claims carefully. First statement, the sum of 2 even numbers is a multiple of 3. Second statement, if 8 exactly divides 2 numbers separately, it must exactly divide their sum. Take a second to guess the correct answer in your head before we reveal it. What do you think? All right, let's check your answers. The first statement is only sometimes true. For example, 2 plus 4 is 6, which is a multiple of 3. But 2 plus 2 is 4, which is not. However, that second statement, it is always true. If you have two multiples of 8, like 8 times A and 8 times B, adding them gives 8 times the sum of A and B. Simply put, adding two multiples of 8 always gives you another multiple of 8.
Let's look at part 5, solving secret letter puzzles, also known as cryptarithms. Consider this fine little puzzle. We have the letters B, Y, and E. Together, this represents a 3-digit number. It's being multiplied by the number 6, and the result equals another 3-digit number represented by the letters R, A, and Y. So how on earth do we find out what numbers these letters are hiding? Well, we use our logic. We can actually break this down step by step. First, let's look at the letter B. B represents the hundreds place. If B was the number 2, then 200 multiplied by 6 is 1,200. But wait, that's a 4-digit number, and our answer, Ray, is only 3 digits long. So B must be smaller than 2. Therefore, B has to be exactly 1. By carefully thinking about the size of the numbers and our multiplication rules, we can slowly deduce the exact value of every single secret letter. And finally, part 6, your turn to explore. Let's see what you can uncover.
You have done a truly wonderful job today, and now you have the mathematical tools to go out and uncover your very own patterns. But before we go, I want to leave you with one final question to think about. What about the product, and by product I mean multiplication, of 3 consecutive numbers, like 2 times 3 times 4? Is the answer always a multiple of 6? Take this final puzzle home with you, use the simple rules we learned today, and see what amazing secrets you can unlock. Thank you so much for learning with me today, and I'll see you in the next explain.